But let's roll the clock a bit forward now. And you're starting to see, by the way, if I just put this is the 16th century, and if we move into just the late 16th century, so remember, we've had Ptolemy for almost 2,000 years. Now we got to the 16th century, suddenly something happens. And the next big thing that happens in our understanding of the universe is a guy called Tycho Brahe exists. So Tycho Brahe is probably the greatest visual observer of all time. This is before the telescope. Brahe observed the planets with exceptional accuracy, using instruments and his eyes, but no telescopes. And the incredible thing, Tycho Brahe himself was a really fascinating character. He lived on an island, the island of Elba, on his own, except it wasn't quite on his own because he had a pet elk. And he used to go drinking with his pet elk. And unfortunately, his pet elk died in a very nice way, but he died when he fell downstairs because he was drunk, because they used to go drinking together. He also had a gold nose because he lost his nose in a duel. So he was a really interesting character, but he was a brilliant observer. So much so that when he published his "Where Are the Planets in the Sky," his protege, who was a theoretician, Johannes Kepler, said, "I'm going to try to bring a model that will fit Tycho Brahe's observation." So here's the problem. Tycho Brahe's observations were so accurate, it said, this doesn't work either. This model isn't good enough. Circles and planets going around in circles, my observations my observations can't be predicted by this. And of course, so Kepler, who believed inherently in Brahe, said, "I want to look at your data." Brahe said, "Not until I die." Kepler said, "I want to see your data, not until I die. I want to see your data." So there's this back and forth, then Tycho Brahe dies, and then Kepler gets his data. So, and what does Kepler do? He thinks about it for a long time, and he said, what if I make an assumption that things go round in ellipses instead of circles? That's all. I'm just going to make one change, ellipses instead of circles. And what happens? Everything falls into place. All the observations of Brahe at their full accuracy simply fall into place. In fact, not only that, but Kepler was then able to use that and some of the associated maths he built around that to predict really accurately where Mars would be in 2 years' time, 5 years' time, which previously you couldn't. Mars would always lose its position a little bit when you try to predict using Ptolemy's model or using Copernicus's model. But come and use Kepler's model and Mars or Jupiter are exactly where you expect them to be. So that gives you great confidence that probably stuff goes round in ellipses and that the Earth isn't at the center of the universe. So we roll the clock on just a few years. We're still in the 17th century. A really interesting time from an astronomy point of view. By the way, when we come to the end of the talk, in a few minutes' time, I'm going to be telling you about why it's really interesting now again. We're at a really interesting time. This is a really fascinating time. So along comes this guy who most of us will know, and those who are very young will get to know this guy very well as you get older. His name is Galileo Galilei. So he was a businessman, a scientist, a philosopher, many different things. It was quite common in those days. And in 1608, he heard of a guy called Hans Lippershey, a Dutch glassmaker, who had talked about being able to see things closer if he used two lenses. And Galileo thought, this is interesting, I need to find out more about this. So he found, using some intelligence, we probably call it today, so messengers back then, that this guy Hans Lippershey had actually invented a magnifying device. He did the same type of thing, but he turned into what, of course, we today would refer to as a telescope. Galileo was interested in looking at the stars, in part, and he realized that this would allow him to see the stars more accurately than previously. However, Galileo was a businessman. One of the things he also did with his telescope was he sold time on his telescope to the noblemen in Venice so that they could see ships coming over the horizon before people could see it with their naked eyes. Why? Because if you see a spice ship is coming in, you know the price of spices is going to tumble because there's going to be a lot of spices on the market. It's basically insider trading of a different name. So Galileo was also a businessman in a good sense, I guess. Is insider trading good? Probably not. But he was a businessman. He had to fund himself, although he had an independent wealth as well. And it was but what we remember him for, in terms of our model of the universe, is he turned his telescope to the skies. And he was the first to do that. And that's what makes him really unique. He saw what some of you saw tonight with the telescope, craters. Why is this important? Well, people previously, although with the naked eye, quite honestly, you could see craters with your naked eye. So people with good vision would have already kind of noticed this. With a telescope, they're absolutely clear. You can see craters, you can see you can see mountains, you can see ridges, you can see all sorts of different structures in the moon. And the Greeks believed that the moon was a perfect sphere. You could measure it more accurately. It's not perfectly spherical for a start. It's slightly elliptical. Like everything almost nothing is round in the universe, by the way. And the moon is slightly, we call it an oblate spheroid. So that's a bit of an exaggeration. It looks round, but it's actually slightly bulky at the equator, just like the Earth is. But he also saw when he looked at the sun, and by the way, let's remember everybody, never ever look at the sun, never ever turn a telescope to the sun, ever. So what Galileo did was he pointed his telescope towards the sun and he shone it out the back and on a piece of paper. And what did he see? He saw these dark spots on the sun. He showed that the sun was blemished. It wasn't perfect. And actually he also understood that the sun rotated. So he could see the spots moving across. So we thought, well, the simplest way to imagine that is if the sun is a ball that's rotating. So he said the sun rotates. So this was new news. The other thing that he did was he turned his telescope to Jupiter. This is actually, I know it's very small, I'm not sure if you can see it at the back, but these are some of his drawings. It sounds like I actually have them at home or something, doesn't it? These are some of his drawings. So these are some of his drawings. You can see this is, well, the big round thing is Jupiter, and the two dots either side are two of what we call the four Jovian moons. So, but what he showed was that if you observe them for many nights, you'll actually see that the simplest way to explain these four dots moving is if they're going around Jupiter. So here you also have a thing where he definitely showed that the moon we kind of knew went around the Earth in some sense, but other stuff goes around other stuff. So the Earth isn't that special. And that was something that was really important. And finally, he saw that Venus has phases. Now if you go out in the morning, if you're up very early, you get your dad out very early, you'll see in the morning that there's a very bright star in the west, and that's Venus. If you look at Venus with a telescope, for example, you'll see over a period of weeks that it'll change size. You can see it's large, and it's a little crescent, a bit like the moon is tonight. And then it gets smaller, but it gets more like a disk. And actually the simplest way to explain that is that Venus is between you and the sun, and as it moves around the sun, sometimes it's in a position where the sun is shining face onto it, sometimes the sun is almost behind it. And so you get phases are perfectly consistent with the sun being at the center, the Earth going around, Venus going around, and Venus being inside the Earth. So these observations by Galileo challenged the Church's view at the time, and also the philosophical view that the universe had somehow a perfection, what they considered a perfection associated with it. One other thing, not such a big deal, but he also noticed that when you turned your telescope, you saw more and more stars. So with the naked eye, how many stars do you think you can see with your own eyes? Rough guess. When you look up in the sky at night, how many stars do you think you can see? 5. Thousands. 5,000. 5,000. Anybody else?
Probably none, light pollution.
Okay, now that's a really interesting answer. So if we went to somewhere that wasn't light pollution, thousands. Okay, well, it's actually, because you know we talk about millions of stars, it is actually only thousands that we see. It's about half. It's about 5,000 in total between the two hemispheres. So when you turn a telescope there, you actually can start to see many, many more stars. Now, why is that important? Well, it tells you, for example, that the stars weren't put there just for you and me to look at with our eyes, which is something the Greeks thought. They're just for our the glory of God and so forth, because there's lots of hidden stuff there, and hidden stuff is something that didn't fit in well with overall models of the universe.